Hello everyone, my name is Galeano. I'm going to talk about Turbulence. I'm going to start with a bit of history. I started on the game industry 17 years ago, working as game developer at Dynamic Multimedia. 6 years later, I moved to Criterion Software, where I became the team leader of renderable graphics. Electronic Arts brought Criterion Software, and I became technical director of EA Tech Graphics. Sorry, hard time. Yep. I co-founded Turbulenz Limited 3 years ago with two of my other colleagues. As you can see from the image at the bottom, the team has grown quite a bit since then. We hired engineers from Sony, Eidos, Square Enix, Lionhead, Electronic Arts, so it's possible to play some of the games using technology that some of our developers have written. So what are we doing at Turbulence? Turbulence is developing a vertical solution for developing, publishing, and monetizing high-quality games to be playable on the browser. Today I'm going to demonstrate two of the games that are already available. There are more games coming, there are more games in development, but these two are available right now on our website, so you can play them. I'm also going to demonstrate a first-person shooter tech demo. The first demo I'm going to demonstrate is called Rush. By the way, I'm going to demonstrate this in real time, so hopefully I will not screw up. This game was published on the Xbox 360. It was developed by Sona Games. Okay, that was a score rush. Everything I'm going to show today was written from the scratch in JavaScript. Everything is using the Turbulence engine, and of course WebGL. Some of the problems we have when we ported score rush to Turbulence were basically you can have more than 8,000 bullets on the screen, hundreds of enemies, and it will be really, really slow to draw this one by one. So we basically use splices and texture atlas for batching quads. And at the end of the day, I think we only do like 10, 12 draw calls because we batch everything quite well. The problem with this is that we have some massive textures. Some of them are 4K by 4K. So using DXT compression was critical for laptop with a lower VRAM. We also reduce the dimensions of some of the textures coming from the Xbox 360 version. All these bullets, all the blending, all the full screen effects, this game is GPU limited. We are working hard still to translate some of the shaders from the Xbox 360 into WebGL. So the next game I'm going to demo today is Space Ark. This game was also released on the Xbox 360, and it was developed by Straw Dog Studios. I'm going to show the basic game mechanics, and then I may jump to other levels to show you the complexity that some of the levels can reach. doing a very good job with this level. I'm going to cheat a bit. As you can see, the levels become more and more complicated. Some of the final levels are incredibly complex, and I will explain some of the problems that we have with them. This level has fans that are moving, it has layers, things that you have to activate and deactivate. So that was a space arc. Some of the challenges we have with the space arc, as you can see, some of the levels became really complex and elaborate, and we have massive problems with the garbage collectors. Some of the pauses were half a second, which is an eternity. All these games are really trying to run at 60 frames per second, and we really had to do something about it. We basically achieved and solved most of the problems by reducing the total number of objects from 4 million to 250k. The way that we did this is basically reducing the number of temporary objects that we created by frame, and we also combined multiple objects and multiple arrays into a single object. Basic pattern was, for example, for vertical systems, instead of using one array for the position, another for the velocity, another for the acceleration, we just use one array for everything. We also use type arrays extensively wherever possible, and we managed to save several hundred megabytes, and now the garbage collector process are less than 50 milliseconds. So you still may miss a couple of frames, but it's far more manageable. This game has about 100 megabytes of texture resident at any single point, and we really needed to use compressed DXT textures, otherwise we'll just not fit in memory in many laptops. So we had problems with the garbage collector when it was kicking in, and we also had problems when it was not kicking in. Sometimes from level to level, we were loading hundreds of, as I say, 100 megabytes of textures or scene information and animations, and the garbage collector was not releasing the information from the previous level, and we had massive problems. So we had to be a bit more explicit about trying to force the garbage collector into release data. We try to explicitly delete and destroy WebGL objects. We set the array sizes to 0, anything we can think of to try to force releasing on memory. But it's still hard. As this game was published on the Xbox 360, some of the models have more than 100,000 vertices. We found out that some WebGL implementations supported 32-bit indices, some don't. It seems that the standard only supports 16-bit indices, so at runtime we have to basically split the models into chunks that fit in memory. This is the next demo I'm going to do is our first-person shooter demo. You may recognize the artwork. It's from Quake 4, developed by ID Software. It was a multi-platform game. I'm going to play this demo in full screen. Dark. Okay. So all the lighting is real time. Okay. We don't have light maps. It's too dark. I moved to another room that have more light. All the shadows are real time. We use other maps. There are tons of particle systems, skin, animated skin characters. Let me fly to a room with a bit more light. What is it? A little bit to that. We implemented 3D physics and collision. Also for this demo, I'm going to fly around the level just to make it slightly faster. The game Wave 4 had a really complex 2D animation and menu system which we managed to emulate. We got most of the functionality on the game working: particle system, rendering effects, animation. I don't know if you can see, but the animated skin character are projecting a shadow into the door and the floors. Everything is, all the lighting is dynamic. These are rotating light. You can see the movement of the shadows on the floor. Each of the rooms have between 10 and 30 lights. That basically allows the artist to do this complexity. Now I'm going to show you some of the details under the hood. So now I freeze the game. All the visibility queries are frozen. So I can basically show you what it was like. The pinky thing is the frustrum, the viewing frustrum. All those boxes were the lights. There are many different kind of lights, spotlights, point lights. You can see that we are cooling the rest of the level. Now I'm going to show you how it looks without the cooling. So I'm going to fly outside of the level. This is the level we have been navigating through. It has thousands of meshes, hundreds of materials. So the cooling system is a portal system is doing a really good job of basically removing whatever is not visible and is not affecting the visible frustrum. Okay, so that was the first person shooter demo. Some of the main issues we had with porting to WebGL is that this level you've seen has 1694 assets to load. That means textures, animations, scene descriptions, GUI definitions, everything. So the way to improve the loading time is basically compression. The browsers will handle GC compression for you transparently, but not all compressors behave the same. We figured out that zip basically managed to save 10-20% when generating GC files, which is a big win. We also focus on caching a lot. When we're using the Turbulenz engine, all the assets basically have unique names, and we ask politely the browser to cache them for 10 years. Sometimes it does it. But another big point is we use archives. In this particular example, one of the archives that we love has 540 textures on it. It's a single tar file that we load in one go, and we basically unpack and extract the textures from it. This helps a lot to reduce the problems with the overhead that HTTP requests have. This particular level, hundreds of lights, hundreds of particle systems, really complex particle systems. So cooling, portals, bounding box tree, it was essential to get good frame rates. The visual complexity, although it was a bit dark, but it's quite impressive. It has 55 different shading techniques and 451 different materials. Some of the materials have diffuse map, normal map, a specular map, a glow map. It's really complicated ones. So all of this was possible by a flexible rendering system. It's really easy to plug and play effects on our renderers. Our shader pipeline is basically based on CGFX files that we compile into a JSON-based format that contains the description of the rendering technique and the GLSL code that is needed at runtime. It's critical to minimize the stage changes with so many shading techniques and so many materials. If we don't sort properly by technique and material, we will spend all the time just submitting state changes. It will be really slow. So it's important to sort properly. The original game supported many different file formats: ND5, PROC, MAP, CM, ASC, LWOs. Some of them binary, some of them text-based. So we basically wrote tools to unify all these formats into a single JSON-based format, similar in a scope to Collada, but in JSON. And we load that at runtime. And that format can contain scene description, geometry, animations, anything. This is a bit of a diagram about the Turbulenz engine. Everything we provide is in red. Your gain is the green box. Below the green box is what we call a classic game engine. Everything you may need to basically develop your game: graphics, physics, animation, audio, math, scene management, resource management. On top of the green box is what we call the internet generation game engine, which is what people call cloud-based APIs. So you can save the game online, so you can keep playing the game from any location. We have leaderboards, badges, we have social features, and all of that is all those APIs are backed by our servers, provide that functionality for you. This is a top-level diagram of the Turbulenz platform. Previously it was the engine. This is the platform. You use a SDK to develop locally. We provide a file server with additional functionality to get metrics, with viewers to help you develop your game. So you test that locally. Once your game is ready, you basically deploy your game to our online development system, which we call the hub. And now your game is in the proper environment. It's online. People can play in the same environment that basically final users will play. Then you're happy with your game. You publish it to our live environment, basically at a Turbulenz game site. And once it's there, it's available to users, and we provide monetization, payments API, we provide analytics, metrics, we provide A/B testing. You can assign 10% of the users to one version, 90% of the users to another version, and you can basically compare the different metrics that you get for each version. Our game set is live right now. It's a bit of a beta state. Turbulenz.com, you can register and play 2 of the games, Score Rush and Space Ark. We update them constantly. Score Rush is probably get a new day soon. We are working on a multiplayer version of it. You can register in our hub, on our online development site. You can download our SDK. You can read our SDK documentation online, docs.turbulenz.com. It's the same documentation that comes with the SDK. And that's all. I hope you enjoy my presentation, and thanks for listening.
Thank you very much. We have time for some questions.
Yeah, a very impressive technology. In your talk, you mentioned that 1 or 2 of the games were originally developed or published for Xbox 360. So did you do a port of the code to JavaScript and WebGL?
Yeah, the developers did the port themselves to JavaScript and Turbulenz our Turbulence engine. They didn't use any automatic tools, so everything was handwritten by hand in JavaScript directly. Did I answer your question?
Okay, next question.
So, what are the pricing model if I, as a developer, want to create a game using your engine?
Yeah, you can download the SDK for free, you can develop for free, and we are basically using a revenue share model. If you make money, you will make money. Until your game makes any revenue, we don't get anything. Probably the next question is how much, and it's a kind of an industry standard 30% at the moment. We're constantly revising and checking our license. We would really want to make it easy for people, but 30% at the moment is kind of the industry standard. If you have developers for the Xbox 360, PlayStation 3, the App Store, they all take a similar cut.
And what about hosting?
We do all that for you. We take care of the hosting, we take care of the metrics, the analytics, we take care of everything for you.
Okay, last question.
How long have you been working on Turbulence?
3 years. When we started, WebGL didn't exist, so the technology has evolved quite a bit. But I think this kind of probably you're talking about the Quake presentation, the Quake demo. That was not possible until a year ago, more or less. But yeah, basically 3 years since we left Electronic Arts to create the company.
Okay. Thank you very much again.
Thank you. By the way, feel free to grab me at any point if you want to play the games, my laptop or anything during the lunch break. Okay? Thank you.